This is 3-4 graphing functions. The first graph that we're going to focus on this year have to do with linear functions. All of these graphs you'll see in this section, but really the whole next few chapters are focused on linear functions, which is y equals mx plus b. I want you to notice that the x has an exponent of 1. It's invisible, but has an exponent of 1. We don't write it. Quadratic functions we'll see later in the year. Quadratic functions have an exponent of 2. So it would look something like y equals x squared. Absolute value functions, you really don't see these too much until Algebra 2, but that might look something like y equals the absolute value of x minus 3, something along those lines. And exponential functions we really don't talk about at all this year. Okay, so it's to graph the function for the given domain. Remember, domain are x values, so this is my first x value, and then we'll have another x value after that. So the domain are the x values. What we're going to do with those first is we're going to isolate y. We're going to get y by itself in this equation, and then we're going to plug in the x value. So step 1, solve for y. So I'm going to take my negative 2x plus y equals 3. If I want y to be by itself, how do I get rid of this negative 2x? We can add 2x to both sides. So to move something to the other side, opposite sign, y equals, opposite operation I should say, but y equals, I'm going to write it as 2x plus 3. I'm just writing it so the x comes first. The 3 is positive, that's how I knew I needed plus 3. But y equals 2x plus 3. That's the biggest thing from this section, is focusing on isolating y. The next big thing for this section would be plugging in the x values. The domain that they gave us was negative 5, negative 3, 1, and 4. Those are my x values. So I'm going to plug that in where x is. What do I get when I plug in x? So 2 times negative 5 is negative 10. Add 3, so negative 10 plus 3, which is negative 7. So y equals negative 7, and so I'm going to write that as my x, comma, and my y was negative 7. So I already have my x. I'm just trying to find my y for all of these ordered pairs. Notice all my ordered pairs have parentheses. Please be careful of that. Okay, now I'm going to plug in negative 3. So y equals 2 times negative 3 plus 3. I'm going to solve this. 2 times negative 3 is negative 6 plus 3. And negative 6 plus 3 is negative 3. Now I'm going to plug in 1 for x. So y equals 2 times x plus 3. 2 times 1 is 2 plus 3, which is 5. So we got 5 for y on that one. And y equals 2 times 4 plus 3. For the 2x plus 3. 2 times 4 is 8 plus 3, which equals 11. So y equals 11. And now we would graph the ordered pairs. Since this is a linear function, there was no exponent there. The exponent was of 1. I know it's a linear function, and so when I graph it, I know I should get a straight line, or I messed up. If we don't get a straight line, we made a mistake. So I'm going to graph negative 5, negative 7. Negative 5 on the x-axis would be to the left, and negative on the y-axis would be going down. That's how I know my negative 5, negative 7 is right here. And then we have negative 3 right here. Notice it's already in a straight line. I graphed my last 2 points, and look at that, it is in a straight line. Since I was provided the domain, because I was given the domain, this is a discrete graph. So as tempting as it is, we cannot connect the dots or we're incorrect. Okay, we were given that domain, so it's a discrete graph. Here's another example. Here we're given the domain. Notice I have an x squared. I already know that this is going to be a parabola. It's going to be shaped like this. This is what we wouldn't really do until later in the year, but we just want to practice plugging in x values. The domain are my x values. So I write those in my table, and again, I'm given the domain, so I know this is a discrete graph. I will not be able to connect the dots. And so I'm going to plug in for each of these. We have to be careful of PEMDAS with exponents. So it's whenever we replace a variable, it's in parentheses. So it's negative 3 in parentheses squared plus 2. Well, let's think about that. Negative 3 in parentheses means, to the second power means negative 3 times itself, negative 3, plus 2. And what's negative 3 times negative 3? It'd be positive 9 plus 2. If you put this in your calculator and you don't use parentheses, if you write negative 3 squared in your calculator, you're going to get negative 9 because that's correct. But if you put negative 3 in parentheses squared in your calculator, you'll get positive 9. There is a big difference on these, so just be careful of that with your calculator. Okay, 9 plus 2 will get me a final answer of 11. My y is going to be, my f of x is equal to 11 basically. So negative 3, 11. Remember, f of x is a function of x. It means I'm plugging in a value for x. And my graph is definitely a function. Okay, so f of x equals, let's do that again with negative 1. Negative 1 squared plus 2. Negative 1 times negative 1 is positive 1 plus 2, which is 3. So my ordered pair this time is going to be negative 1, and my f of x value, or my y value, is 3. Plug in 0. F of 0 equals 0 squared plus 2. 0 squared is 0 plus 2 is 2. 0 squared means 0 times 0. So I get 2 on this one, 0 comma 2. And f of 1, now I'm plugging in. You can leave f of x or f of 1. It doesn't really matter on that one. But I am plugging in my 1 squared plus 2. Well, 1 squared means 1 times 1, which is 1, plus 2. 1 plus 2 is 3. Okay, so we have 1 comma 3 on that one. And f of 3 is equal to 3 squared plus 2. 3 squared, 3 times 3 is 9, plus 2, which is 11. So I got 3, 11. It's very important that we replace the variables with parentheses. Let's see what this looks like as a graph now. So negative 3, 11. It's going to be off the charts here, but that's okay. We get the idea. It's approximately right there. Now we do not connect the dots because this was a discrete graph. In summary, what this is saying is for a continuous graph, you want to have arrowheads to show that your line can go on forever. So here we're told to graph the function, but we're not given a domain. We can pick any real number that we want to. So I can pick negative 2, negative 1, 0, 1, 2, 3. But you could pick any other numbers if you wanted to. I'm just randomly choosing those numbers for my x values. And then I'm going to plug it in to equal my f of x. So negative 3, I'm plugging in negative 2 from right here into the spot, plus 2, to see what this will equal. Well, negative 3 times negative 2 is positive 6, plus 2 is 8. So I end up with negative 2 for my x, which resulted in an 8 for the y. Let's continue this. Notice that I am replacing all of my variables with parentheses. Also notice that my y values have a pattern. They're all decreasing by 3 every single time. If we have a pattern in the x, we're going to get a pattern in the y if it's a linear equation. And I know this is linear because my exponent of x is 1. So now we're about to graph all of these points, but keep in mind that someone could have picked different points than me. This is what makes us continuous. It could be any x value since we weren't told it had to be specific x values. We were not provided a specific domain. So notice that my line is a straight line since I knew this was a linear equation. That's good. And I'm going to connect because I made up the x values. No domain was provided, so this is continuous. This is a continuous graph. And I show that with my arrowheads on either end of the line. So remember in the beginning I told you that this would be rare because it's more algebra 2, but there are times where we'll have an absolute value equation. When you graph an absolute value equation, it results in the shape of a V graph. So we were not provided a domain, so I can pick any x values that I want to. I usually pick these every time. So it equals the absolute value of negative 2 plus 2. Well, the absolute value of negative 2 is positive 2. So this turns into 2 plus 2, which is 4. So we have negative 2, 4. And let's continue this. So using these points that I've come up with, I'm going to now graph them. So notice it's shaped like a V, and since I made up my own x values, I was not provided a domain, then I'm going to connect with arrows to make it a continuous graph. Example 3, use a graph of the function f of x equals negative 1/2 x plus 4 to find the value when x equals negative 4. So the graph is already plotted for us, and it says when x is negative 4. Well, if I follow negative 4 up to the line, I know that f of x, or y, is going to be equal to 6. Now I can check that. So f of negative 4 should result in 6. So let's plug that into C. F of x equals negative 1/2 times my x value, which is negative 4, plus 4. Negative 1/2 times 4 is positive 2. And so this comes out to be 6, so it's perfect. So to find f of negative 4, it's like plugging in negative 4 for the x. So I can go to negative 4 on the graph, go up, and I end up at 6. Okay, so we're given a function y equals 6x in this problem. Describe the distance y lava moved on average in 6 of x hours is what it represents. Use the graph to estimate how many miles the lava moved after 5.5 hours. So after 5.5 hours, we're talking about somewhere around here, so maybe 33 miles. Sorry, I just realized it's meters, not miles. Well, the word problem says miles, so I suppose the answer should say miles as well. So it's 33 miles in 5.5 hours.